Hello, I'm Johnny Duke, and in this segment we're going to be looking at transformations of the exponential functions that we were just looking at. Transformations of exponential functions are just like transformations of other functions we've had in algebra. They're going to look at vertical shifts and horizontal shifts and reflections through the x and reflections through the y-axis. I prepared a geometer sketchpad animation to show us each one of those. So let's look at that animation. As you look over here in the upper left-hand corner of the screen, we have we're going to be looking at a vertical shift. Remember, a vertical shift affects y. And so if our function is f of x equals e to the x, if I take another function and say that is f of x equals e to the x, and then add a number to it, I'm going to find a y value and add the same number every time. So let's look at our plot of our function. We're starting out where h of x, our vertical shift, is none because we have 0 being added. Now notice what happens as we add positive numbers. In other words, we'll have h of x equals e to the x and then add a positive number. And notice that our function goes up. And so let's stop it right there. There's an important point on your screen. As you look on your original function, f of x equals e to the x, we have the point 0, 1 right here. If you will look, when we have e to the x plus 4, that point has now gone up 4 units. Hence a vertical shift up 4 units. Pay attention to this point on the y-axis as we continue the animation. And notice that point is changing with the number that we have. And finally, when we go below, we have a negative number. E to the x minus 3 then takes that point, 0, 1, and every other point on this blue line, moves it down 1, 2, 3 units, hence the negative 3, vertical shift down 3 units. And every point on this orange line is exactly 3 units below its counterpoint on the blue line. So we've seen a vertical shift occurs after we've raised our function e to the x, and then we add or subtract a number from that. Now, let's hide that one, and let's look over at a horizontal shift. As you look on your screen, the horizontal shift, notice now the number we are adding will be up with x. It's a part of our exponent. And so it affects what we're taking e to the value of, which means it's affecting x itself. And since x is going horizontal axis, we'll be looking at horizontal shifts. So let's start with our function. Right now we've got e to the x plus 0, which is simply our f of x equals e to the x. But notice as soon as I animate this, we get a function like f of x equals e to the x plus 3. And you will notice that as soon as I animated it, even though my numbers that I am adding to x in the exponent are positive, surprisingly, my shift is going to the left. We would expect it to go to the right. But on horizontal shifts, it goes to the opposite direction of the number that you're looking at in the exponent. Let's continue it. Now, notice that as my number becomes, here in just a moment, negative, we're going to have horizontal shifts, but we're going to be going to the right. And so we have, for instance, let's stop it here, e to the x plus negative 4, or of course we could just write that e to the x minus 4. We have a horizontal shift because our negative 4, or our 4, is being added in the exponent, and our point on f of x equals e to the x, which is 0, 1. That reference point now is shifted 1, 2, 3, 4 places to the right. So we've seen a horizontal shift is affecting x, and it goes in the opposite direction of the number that we've been looking at. Now let's look at what happens if we reflect our function. Let's start with, down here in the lower right hand corner, if you're looking at the screen, we'll be looking at a purple graph here in just a moment. We've got s of x equals negative e to the x. Now remember, our parent function up here, f of x equals e to the x. So what we're really doing is taking the opposite of f of x, or minus f of x. So s of x equals negative e to the x, and when we plot that function, notice it reflected through the x-axis. Similarly, notice if our negative, let's look at a reflection through the y over here in the lower left corner, our red function, r of x will equal e to the, now I've put the negative in the exponent. And when we show that function plot, notice that it is a reflection through the y-axis itself. Now, let's go back and practice that with some particular values that you would have. Let's describe these functions in words. Now we're going to start with our parent function. In this case, f of x is 2 to the x. So we're going to let g of x equal f of x plus 1. Or rather than g of x will equal 2 to the x plus 1. Now in this case, we're looking at a horizontal shift to the left 1 unit, because our value that we added, the 1, is in the exponent. It's affecting x then. So g of x equals f of x plus 1. Now notice the plus 1 is outside of our parentheses, which means g of x equals 2 to the x, there's f of x, and then plus 1. And as you have, I hope, already seen, that is going to be a vertical shift to up 1 unit. And our next one is going to be then g of x equals f of x minus 2 plus 3. Now we've got 2 shifts involved. First of all, inside the parentheses, we're subtracting 2. As you recall, that is a horizontal shift, and horizontal shifts go the opposite direction of what we think it would do, and so instead of going left, it's going right. And we have outside of parentheses adding 3, which is a vertical shift, which goes exactly as we would think it would. And so we then have a horizontal shift to the right 2 places, a vertical shift up 3 places. And finally, we could look at g of x equals minus f of x, or g of x then is the opposite of 2 to the x. And in this case, as you recall, that is going to be a reflection through the x-axis. So if we look at that graph real quickly, that means if this is 2 to the x, our new function is reflecting through the x-axis. Like that is how it would look. We've got one more, and that is going to be g of x equals f of negative x. Notice now the negative is in the parentheses, which means it's affecting x, and g of x equals 2 to the negative x. And what we'll have in that case is a reflection through the y-axis. So we've seen that It's just like other functions that we've had. F of x equals x squared. If I take f of x equals x squared and then add 1 to it, it's going to be a vertical shift up. Or if I take f of x equals x to the 2 plus 1, it would be a horizontal shift. And then, of course, the reflections. The next lesson, we're going to be looking at applications of these exponential functions we've been studying. Thank you.